Outside the rink area in the stadium, there are many food and catering services such as a pizza, hot dogs, and a burger restaurant, as well as a Tim Hortons, which all need a power supply.
Besides any consumption used inside the arena, there are all these places that use high consumption that reduce the efficiency of the building as a whole.
A good solution is using the sound coming from the crowd to convert into energy. During concerts and Senators games, there can be up to 17,000 fans in the arena, making a lot of noise. Piezoelectric and triboelectric energy harvesting devices have been developed to convert mechanical energy into electrical energy. In this case, our mechanical energy will be the vibrations of the stadium.
There can be sensors installed throughout the building that will allow for the HVAC system usage to be controlled automatically based on the population in the room.
This can also be considered for bathrooms and other rooms where we can control the lighting using dimmers and automatic switches for vacant rooms with occupancy sensors. To put this into perspective, for example, using T5HO fluorescent high bays where we can have 5 units of 6 lamp 340 watt high bays, we are looking at a utility rate of 10 cents per 1 kilowatt hour. This is considering 50% of them are at high usage and 50% of them are at low usage. Without occupancy sensors, we have around 50,000 kilowatt hour, which costs about 5,000 USD per year just to keep the lights running. If we consider only half of those 50 lights to be equipped with occupancy sensors, meaning half of the lights are off about 70% of the time, we are looking at a cost of approximately $3,200 per year, and this is a much smaller scale than an actual stadium. That being said, we are saving a lot of power and money using Siemens' building technologies, which consist of dimmers, switching actuators, and lighting control machines.
The Canadian Tire Centre is surrounded by 500 acres of open land. We can use this opportunity to install an array of wind turbines that theoretically is able to produce enough energy for a small neighborhood. This means that we can work wonders for the single stadium.
Comparing this project to what is done in other stadiums, we can estimate an average turbine height of 15 feet with a vertical axis design and weighing about 1,000 pounds, which allows to produce more than enough energy than what is consumed for the games and concerts all year. In this case, using a 10 kilowatt wind turbine, which costs approximately between $40,000 and $60,000 to install, the equipment cost is about $40,000 and the rest is shipping and installation. By installing just 10 turbines, we will be saving approximately $1 million a year.
By installing approximately 500 solar panels on the CTC's large roof, we would be saving approximately $20,000 a year. With installation and equipment expenses, the whole project would cost approximately $260,000. Coating the windows is also a good way of transmitting less UV light into the building and reducing heat gain. The Canadian Tire Centre has a lot of room on the roof and is not surrounded by any high-rise buildings that could potentially get in the way of the sunlight. This means that it is possible to install solar panels to absorb any potential heat that can be converted into energy for the building itself.
By implementing these modifications, the Canadian Tire Centre has a potential of obtaining a LEED certified silver certification for existing buildings.